Tuberculosis, also known as TB, is an infectious disease. TB is one of the top 10 causes of death in 2018. About 1/3 of the world's population are infected with TB, resulting in more than 1 million deaths per year. TB bacteria can be expelled into the airway in tiny water droplets from an infected person and remain floating in the air for several hours till it's inhaled by a nearby healthy person. Although the high death toll and the highly infectious disease, basic diagnosis of TB has not changed for more than a century. The classic skin test's result takes from 2 to 3 days and is not 100% accurate. The treatment usually takes 6 months, during which some patients develop multiple drug resistance and can only then be cured with the second-line drugs, which are more expensive and have more side effects, making the need for a reliable TB diagnostic tool a must. Erythra has developed a new diagnostic test with 99% sensitivity and specificity. It is simple and it takes 5 to 15 minutes. Unlike other diseases' diagnostic tests, our tests do not need any equipment and can be done by a nurse or by the patient himself. This test will decrease the incidence of TB as it can diagnose TB very early and monitors the treatment. At the cost of $10 for the semi-quantitative one, it can tell if the disease is mild, moderate, or severe. And to turn it to a fully quantitative, you should buy the machine that costs only $600. Our test is considered relatively very cheap. Other tests are less sensitive, take longer time, need professional personnel, and are qualitative only. Further, the molecular tests cost more than $50. ErythraTB test is a lateral flow assay test with higher efficiency and 83% cost reduction in the quantitative results. With such attributes, we will contribute to end the TB epidemic by 2030, as this is among the health targets of the Sustainable Development Goals. The theory behind ErythraTB test. Lymphocytes are a type of white blood cells. Lymphocytes produce antibodies against foreign antigens or foreign bodies. Antibodies can track foreign antigens all over the body and enable the immune system to destroy them and store this information in their memory for any possible future invasion. Every antigen has a specific antibody, like a key and a lock. But why the body sometimes allows foreign bodies in, like bacteria or even cancerous cells? It's known that if an antigen reached the thymus gland, the central part of the immune system, its lymphocyte sacrifices itself by suicide, a process called apoptosis. In other words, the body stops fighting that foreign body. Still, the question is, how do a foreign body circulates around the body until it reaches the thymus gland without being attacked and destroyed by the antibodies? We discovered that red blood cells, RBCs, transport those antigens of the foreign body, or in other words, the antigens of the foreign bodies hide inside the red blood cells to reach the thymus glands and get neutralized. It all started with us studying pregnancy. We found that the mother erythrocytes carry the fetus antigens to induce tolerance and enable the fetus to survive in the uterus. In fact, the fetus is protected like any organ or as part of his mother, although it's technically a foreign body. And that led us to the discovery of how the antigens of any foreign body hides inside the red blood cells. Hence, by looking for certain antigens in the red blood cells, we detect if these foreign bodies are in the body or not. Our test detects the antigens of TB bacteria in the red blood cells and hence indicates if the patient is infected or not. This theory can be applied to detect many other diseases and, most importantly, cancer. Cancer is a leading cause of death worldwide, accounting for an estimated 6.9 million deaths in 2018. That's why at Erythra we are already developing a test for cancer. Applying the same theory, we could detect and diagnose the cancer at a very early stage. We are hopeful that in the future, not only succeed in developing our tool to diagnose, but actually to cure cancer.